Kombucha.
Kombucha, Chinese, chájūn, Korean, beoseotcha, is a lightly effervescent fermented drink of sweetened black tea that is used as a functional food. It is produced by fermenting the tea using a symbiotic colony of bacteria and yeast, or SCOBY. Although kombucha is claimed to have several beneficial effects on health, these claims are not supported by scientific evidence. Drinking kombucha has been linked to serious side effects and deaths, and improper preparation can lead to contamination.
Etymology.
In Japan, kombucha, Kombucha. Kelp tea refers to a different beverage made from dried and powdered kombu, an edible kelp from the Laminaceae family. For the English word kombucha, first recorded in 1995 and of uncertain etymology, the American Heritage Dictionary suggests, probably from Japanese kombucha, tea made from kombu, the Japanese word for kelp perhaps being used by English speakers to designate fermented tea due to confusion or because the thick gelatinous film produced by the kombucha culture was thought to resemble seaweed. The proper Japanese name for what English speakers know as kombucha is kocha kinoko honka kinoko, literally, red tea mushroom, compounding kocha black tea, and kinoko wrong mushroom. Toadstool. The Chinese names for kombucha are hongsha-jun honka-jun, red tea fungus, kamiya-jun kamei-jun, tea mold, or honkagyu honkagai, red tea mushroom, with jun-jun fungus, bacterium or germ, or jun mushroom, mei-jun meri-jun mold or fungus, and gai-gai mushroom. Red tea, honka, in Chinese languages corresponds to English black tea. A 1965 mycological study called kombucha tea fungus, and listed other names, teasham, Japanese or Indonesian tea fungus, kombucha, wonderpilz, hongo, kajij, fungus japonicus, and tea kwas. Some further spellings and synonyms include kombucha and shambuko, and heipao, kagesuk tea, kwasan, Manchurian fungus or mushroom, spoomto, as well as the misnomers champagne of life, and chai from the sea.
History.
Kombucha originated in northeast China or Manchuria and later spread to Russia and from there to the rest of the world. In Russian, the kombucha culture is called chájūn grib chain grib, lit tea fungus mushroom, and the fermented drink is called chájūn grib, fungus mushroom, or chájūn kvass chain kvass, tea kvass. Kombucha was highly popular and seen as a health food in China in the 1950s and 1960s. Many families would grow kombucha at home. It was brought to Russia sometime before 1910 and spread from there to Germany and Europe. Some promotional kombucha sources suggest the history of this tea-based beverage originated in ancient China or Japan, though no written records support these assumptions. See History of tea in China and History of tea in Japan.
Chemical and biological properties.
The kombucha culture is a symbiotic culture of bacteria and yeast, SCOBY, comprising Acetobacter, a genus of acetic acid bacteria, and one or more yeasts. These form a zoogleel mat. In Chinese, this microbial culture is called haomo in Cantonese, or jiaomu in Mandarin, Chinese, xiaomu literally, fermentation mother. It is also known as Manchurian mushroom. A kombucha culture may contain one or more of the yeasts Saccharomyces cerevisiae, Brettanomyces bruxellensis, Candida stellata, Schizosaccharomyces pum, Terulis bradelbrooka, and Zygosaccharomyces baylor. Alcohol production by the yeast, S, contributes to the production of acetic acid by the bacteria. Although the bacterial component of a kombucha culture comprises several species, it almost always includes Gluconastobacter xylinus, formerly Acetobacter xylinum, which ferments the alcohols produced by the yeast, S, into acetic acid. This increases the acidity while limiting the alcoholic content of kombucha. The count of bacteria and yeast that were found to produce acetic acid increased for the first 4 days of fermentation and decreased after. Sucrose is broken up into fructose and glucose, and the bacteria and yeast break glucose into gluconic acid, and fructose into acetic acid. G-xylinum is responsible for most or all of the physical structure of a kombucha mother, and has been shown to produce microbial cellulose. This is likely due to artificial selection by brewers over time, selecting for firmer and more robust cultures. The acidity and mild alcoholic element of kombucha resists contamination by most airborne molds or bacterial spores. It was shown that kombucha inhibits growth of harmful microorganisms such as E. coli, Salenteritidis, Saltivimurium, and Sh. sonu. As a result, kombucha is relatively easy to maintain as a culture outside of sterile conditions. The bacteria and yeasts in kombucha promote microbial growth for the first 6 days of fermentation. After that, they steadily decline. Kombucha even has this antimicrobial effect after being heated and at a pH of 7. While this beverage inhibits growth of certain bacteria, it had no effect on the yeasts. This study also found that large proteins and catechins such as epigallocatechin gallate also contributed to the antimicrobial properties of kombucha. The kombucha culture can also be used to make an artificial leather. Kombucha contains multiple species of yeast and bacteria along with the organic acids, active enzymes, amino acids, and polyphenols produced by these microbes. The precise quantities of a sample can only be determined by laboratory analysis and vary depending on the fermentation method, but kombucha may contain any of the following: acetic acid, ethanol, gluconic acid, glucuronic acid, glycerol, lactic acid, arsenic acid and B vitamins. It was also found that kombucha contains about 1.51 mg per milliliter of vitamin C. Another main ingredient found in all fermented foods and beverages are probiotics, which are beneficial bacteria necessary for adequate digestion and absorption of nutrients. They are viable microorganisms that improve gut microflora by secreting enzymes, organic acids, vitamins, and non-toxic antibacterial substances once ingested. Probiotics have also been shown to improve metabolism and treat antibiotic-associated symptoms such as diarrhea. In a recent study, alternative diets such as probiotics, green tea extract and kombucha tea were fed to broiler chickens to measure the effects of growth and immunity. The chickens fed with kombucha showed an increase in protein digestibility. The conclusion of the study stated, adding kombucha tea, 20% concentration, to wet wheat-based diets improved broiler performance and had a growth-promoting effect. Probiotic diets also resulted in enhanced growth and performance, but to a lesser extent. According to the American Alcohol and Tobacco Tax and Trade Bureau, many kombucha products contain more than 0.5% alcohol by volume, but some contain less. Many claims have focused on glucuronic acid, a compound used by the liver for detoxification. The idea that glucuronic acid is present in kombucha is based on the observation that glucuronic acid conjugates, glucuronic acid waste chemicals, are increased in the urine after consumption. Early chemical analysis of kombucha brew suggested glucuronic acid was the key component, and researchers hypothesized that the extra glucuronic acid would assist the liver by supplying more of the substance during detoxification. These analyses were done using gas chromatography to identify the chemical constituents, but this method relies on having proper chemical standards to match to the unknown chemicals. Reports of adverse reactions may be related to unsanitary fermentation conditions, leaching of compounds from the fermentation vessels, or sickly kombucha cultures that cannot acidify the brew. Cleanliness is important during preparation, and in most cases, the acidity of the fermented drink prevents growth of unwanted contaminants.
Health claims.
According to the American Cancer Society, kombucha has been promoted as a cure-all for many conditions, but while no randomized, case-controlled studies have been published in relation to its effect on humans, there has been suspicion in isolated incidents of its effect on the central nervous system, liver, metabolic acidosis, and toxicity in general, though no specific links have been established. Acute conditions, such as lactic acidosis, caused by drinking of kombucha, are more likely to occur in persons with pre-existing medical conditions. Other reports suggest care should be taken when taking medical drugs or hormone replacement therapy while regularly drinking kombucha. It may also cause allergic reactions. Some adverse health effects may be due to the simple acidity of the tea, which may be mitigated by avoiding over-fermentation when preparing it.
Brewing kombucha.
Kombucha is typically produced by placing a culture in a sweetened tea, as sugars are necessary for fermentation. Black tea is a popular choice, but green tea, white tea and yerba mate may also be used. Herbal teas or those treated with oils may harm the kombucha culture over time. A standard kombucha recipe calls for 1 cup of sugar per gallon of water or tea, though some variation in the ratio is tolerated by the culture. Kombucha may be fermented with many different sugar sources, including refined white sugar, evaporated cane juice, brown sugar, glucose-fructose syrups, molasses and honey, pasteurized only. High concentration of honey and its bacteriostatic agents may potentially disturb the stability of the culture. Pure agave also can be used. Kombucha should never be fermented with stevia, xylitol, lactose, or any artificial sweetener. The container is often covered with a closed weave cloth to prevent contamination by dust, mold, and other bacteria, while allowing gas transfer, breathing. A baby, new layer of the SCOBY, is produced on the liquid-gas interface during each fermentation. The surface area is the most favorable location for both aerobic bacteria on the top of the new pancake, and anaerobic bacteria on the bottom. The surface area also has ideal concentration of oxygen for the yeast in the matrix to propagate readily. After a week or two of fermentation, the liquid is tapped. Some liquid is retained for the subsequent batch to keep the pH low to prevent contamination. This process can be repeated indefinitely. In each batch, the mother culture will produce a baby, which can be directly handled, separated like 2 pancakes, and moved to another container. The yeast in the tapped liquid will continue to survive. A secondary fermentation may be accomplished by removing the liquid to a closed container, bottle, for about a week to produce more carbonation. Care should be taken, as carbon dioxide buildup can cause bottles to explode. Left entirely alone to ferment with oxygen, the kombucha settles into months of production time, the baby thickening considerably, creating an ever more acidic and vinegar-flavored cider. At any point the kombucha can be tapped or have tea added. Liquid from the previous batch will preserve some of the culture.
Safety and contamination.
As with other foods, there is a risk of contamination during preparation and storage. Key components of food safety when brewing kombucha include clean environment, proper temperature, and low pH. If a culture becomes contaminated, it will most likely be identifiable as common mold, which is often green, blue, or black in color. This is visually distinct from the brownish root filaments on the underside of the culture. If mold does grow on the surface of the kombucha culture, or mushroom, both culture and tea are disposed of and the maker must start again with a fresh kombucha culture. There is a greater risk of mold growth when the kombucha mushroom is lifted out of the liquid by its own gases, thus keeping it covered with liquid in the later stages, that is when the new kombucha mushroom starts growing, can successfully prevent mold from growing. The low rate of contamination by the home brewer might be explained by protective mechanisms, such as formation of organic acids and antibiotic substances. Thus, subjects with healthy metabolisms are appropriate for cultivating kombucha tea cultures to drink the product tea. However, those suffering from immunosuppression should preferably consume controlled commercial kombucha beverages. In every step of the preparation process, it is important that hands and utensils, or anything that will to come into contact with the culture, be well cleaned to prevent contamination of the kombucha. Also, kombucha becomes very acidic, approximately penthouse 300 when finished, so it can leach unwanted and potentially toxic materials from containers in which it is fermenting if they are not food grade. Food grade glass is very safe. Other acceptable containers may also include lead-free china or glazed earthenware, raw wooden bowls, and stainless steel. Keeping cultures covered and in clean environments also reduces the risk of introducing contaminants and insects. Maintaining a correct pH is an important factor in a home brew. Acidic conditions are favorable for the growth of the kombucha culture, and inhibit the growth of molds and bacteria. The pH of the kombucha batch should be between 2.5 and 4.6. A pH of less than 2.5 makes the drink too acidic for normal human consumption, while a pH greater than 4.6 increases the risk of contamination. Use a fresh starter tea, and/or distilled vinegar can be used to control pH. Some brewers test the pH at the beginning and the end of the brewing cycle to ensure the correct pH is achieved and the brewing cycle is completed.